The question, example 12, the question did not ask for regression line because regression line already given. But they want to find P, which is the missing value. How do you do it? Correct? Because, so easy. If P is given, then just enter GC, done, do it or you. But now P is missing. The most important thing we need to make use of for this example is that the regression line, whether it is whether it's M on T or T on M, it must pass through a special point. What is the special point? T bar, M bar. No matter what. We are going to make use of this. Look, how do you calculate the mean value of T? You already have 5, 6, 7, 10, 11, 12, 13, 16. This one can be found using GC. Therefore, mean of T, quite obvious, is just 80 divided by 8, which is 10. Follow so far? But what about mean of M? You have 68, 68, 69, 72, P, 72, 76, 77. Summation M is just these numerical values plus a value P. And M bar, which is the mean of M, is 503 plus P divided by 8. This is the total number of points. Follow so far? So, and you are given the regression line equation. Does it make sense that if regression line passes through T bar and bar, this pair should satisfy this equation? So we substitute, isn't it? So we substitute. Correct? T bar, M bar lies on a straight line, therefore it must satisfy this. What is M bar again? I say this is 503 plus P divided by 8, 0.94. This must be 10 plus 62.6. One equation, one unknown. You get P equals to 73. Find the difference in mark. I'm talking about this part, okay? Which regression line should we use for this part? The thing here is they didn't ask you how many hours the student, or rather, what is the mark of day if the student studied for 2 hours? Actually, it's 2 more hours. So it is about, sorry, I'm a bit, sorry, let's go back. Write down the equation of this on this. By GC done. This is by GC. So you have 2 regression lines. Shall we just recap? M on T, you have M equals to 0.94 T plus 62.6. T on M, you have T equals to M minus 62. Now you have to make a choice for this next part. Can I have attention, please? For this next part, which one do you use? M on T or T on M? Because it makes a difference. What I'm saying? To decide, again, you have to ask yourself this important question. Is there independent or control variable? Then you have a question. In your question, what does it say? Look up, here. An investigation on the number of hours spent studying for exam for each students. Nothing is mentioned about which is independent. When you collect data again, you will collect exactly this student, how much time you use, how much mark you get. Another student, random B, another student, time used, mark. There is no independent or control variable in this context. No, don't have. During the data collection, what you collect is just one pair of ordered result, ordered pair like that. So, if there is no independent or control variable, in order to estimate what is the change in marks when he studied for 2 more hours. When you say these 2 more hours, you come about change in t equals to 2. That's why I write here, change in t equals to 2. And you are to use this regression line. Because we are talking about change in t. Whether it's t or change in t, you are trying to find change in n given change in t, you will use this regression line. Not the one below, even though you just found this. Follow? So, a change in 2 here, correct, will result in a change in mark of 0.94 times 2. Because this is the gradient of the graph. Oh, this is the gradient of the graph. So, gradient of which line? Gradient of the regression line. This line must be very specific. This line is actually your m equals to 0.94 t plus 62.6. This is the line we're talking about. Okay? Gradient is 0.94. Therefore, look, if this were your graph, this is t, this is m, your gradient is like that. Gradient means for 1, this is 0.94. Correct? If this is 2, then you know it's 0.94 times 2. Follow what I'm saying? Okay? This one must be 0.94. Another 3 students were surveyed. So total now there are 11 students. Give a sketch of the scatter diagram of the 11 students and calculate the product moment correlation of the data. So assuming we get this, can, by GC, R is 0.882. Okay? It's not quite easy. Just key in. State with the reason which of the models is appropriate. Let's look very carefully. Can I have attention, please? Last part. Give me 2-3 more minutes and we're done. Thank you. Let's go by elimination here. Let's go start from C. If it is a m equals to ln t graph, the ln graph should look like this. Correct? Ln graph should look like this. That means the gradient is decreasing. But if you look at your scatter diagram, it's like that. Oops, what just happened? Never mind, you know what I mean. Okay? You know what I mean, right? Yes? So it cannot be, if it's a ln t, it is like that. So it is not C. Okay? What about a reciprocal? Let's look at B. Let's look at B now. Reciprocal means as is like that. As t increases, correct? M should decrease. Also clear cut cannot be used. So it must be a quadratic. Because quadratic, if B is positive, If B is positive, A is like that. Correct? So how do we explain the choice of A? Like this. The choice of A is because the gradient is increasing, just like the gradient of a quadratic graph. For the most appropriate model, determine the least square estimates of A and B. Look here. If you choose A, then you got to find the regression line of M on T square, right? Correct? M on T square, not on T now, because you're going to code it. Alright? You're going to transform it to a linear model. So you're going to have M on T square by GC, just enter, no problem, is this. State the product moment correlation coefficient. No problem, this is again by GC. And also find the least square estimates of A and B. I'm not going to go through, but quite easy. Right? This should be your A. This should be your A. This should be your B. Right? So, A is this, B is this, R is this, just by GC. I'm going to take 2 more minutes. Okay? Give me 2 more minutes, I'll finish. There's this one last thing you need to copy. It's about the commenting on the value. Look, the question has a certain flow to it. Initially, they asked us to calculate the product moment correlation of y on x. Sorry, m on t. And you got 0.8 something. Then after you transform it, you realize that your r is 0.919. You're supposed to comment on its value. You have a measure this. When you comment, you're not going to just say that it's close to 1. Yes, it's close to 1. But you're going to say that it is closer to 1 compared to the earlier 0.8. Follow what I'm saying? Yes? So therefore, then you say that, okay, it's the model, the projected model is approved. Okay? So, I'm going to let you copy now. Sorry, it's a bit rushed today. I really need to complete this mentally so that revision can start.